All right, let's do a simple verification of doing an analog design in the Skywater 130 nanometer Cadence PDK. Um, so first things first, you need to download one of these tiles, right? The smallest analog tile you can buy is a 1x2. All right, so I'm not going to show you how to do, everything, but that's the first thing you got to do. And I'm just going to get rid of that. So I've started Cadence, and I want to import that file, and it's a def, and let me see, I had uploaded it higher. Where did it go? Nope. Sorry, this video is more just for me to remember what it is I'm doing so that I can go do a real video. But here's the def file I downloaded, right? And then the target library name, I've already created something called Sky Test where I'm keeping everything. Target library path, I think I just left it right there. Reference technology libraries, I just left it right there. Actually think that's all I did. Let's see if it overwrites it or complains. So there's some warnings about things missing. That's okay. So if I double click on that, this should be the pad frame, or the mini pad frame that goes inside the larger tiny cheap ecosystem. Now you can't see the pins, so I'm just going to left select everything, and you can see just barely, maybe I can zoom in a little more, I've selected every pin. All right, and then if you press Q, you can kind of see what all the pins are. Now I did do something, I kind of overwrote my design that I had been doing before. In a way, it's a good thing though. Is that I don't know if this is important, but if you follow the Tiny Tapeout tutorial, all of these have brackets, right? And so I went and edited this to make sure that everything had a bracket, and then I promptly just overwrote it a second ago. So it took a while, but I just went through every pin and changed every single one of these to another name with the brackets. And then you kind of want to orient yourself. You're supposed to short every digital output pin, and so you might be trying to figure out which one is which, right? So it's those, I think. So if I just select that one, press Q, that's UIO input. So that's an output pin. We don't have to worry about it. An input pin, I should say. And that's the first output pin. So from here to the left, all of those need to be shorted to V ground. Now I'm inside the pad frame here, and so when you're inside the pad, when you place this part hierarchically, you can't see what the names of the pins are. I guess you could flatten it, but I like to keep things hierarchical. So that's the first output pin. And so what I do is I just made a rectangle right there to remind myself what I put there. That I know that all of these, because I'm not using any digital pins, need to be shorted to V ground. All right. And so I can just save. Right. Now I was just doing a so here's in this particular, so here I added that file. Right, I added that layout. Okay. And you just stamp it down. And then you've got to all right. So fortunately for me, it looks like it loaded in a def file because you don't see a rectangle there. If I just send edit into this, and again, sorry, this is a very rough video. If I just send in it, highlight, and press Q, all those things are still there. All right. So it could be, I don't want to wipe it out, is that you have to go back, import def, and if you type in, you probably need to type in layout here, right? Or maybe not. We can check that right now. Is that so if I go edit hierarchy return so it's allowing me to put the def in, which I'm just going to click that F and then zoom in here. So it allows you to do that. Either way, you're going to have to change those pin names. I imported it as, so I did a path of metal 4 and just shorted everything, right? And then here I created just to reconfirm, right? Recreate pin, right? It would be, and you got to, you know, VGND, create the label, options, metal 4, stick, layer purpose. All right, and I would add the ground pin and the V power pin, and they're there. I'm pretty sure you got to have that label correctly, because I think they automatically wire the power and the ground to what you call power and ground. And then just, I use paths. I just use 2 microns wide because that was a, you know, it has to be between, I think, 1.2 and 2. Both of these have to be 2 microns wide and 95% of the cell height, which looks like I've got it. All right. And then I was just trying to do the simplest thing possible, and I created a directory that used the first two analog pins, and I just put them, we can call it a short or a metal resistor, right? Just to verify everything. So once those are all saved, right, you can export. So if you want to, you got to export the LEF, right? That was my top layer. Those are the two views that I want to make sure that it captures. I switch it to 5.8. I clicked on cells so that I clicked on the one I wanted. 5.8 cells and design, and I just press OK, and I get two warnings, and one looks serious. It says there's this layer, polycut oxide. I decided to ignore it and see what happened, because it didn't seem I was using polycut oxide. Now maybe for a real design with transistors in it, it's there, but I searched all over for that layer and couldn't find it in the LEF file. Then when you want to export the GDS, and you could export your designs to GDS and then use Magic to assemble it like in the video. That's probably what I'll do in the future. Export. So if you want to export the GDS, that's called stream in Cadence, and so that's the stream file. I keep everything that same name, right? That's the library it comes from. That's the top cell, the layout view. You get to choose the technology. That's what I called my Skywater, right? S130, and audit things just automatically work. When you do translate, I got no errors and no warnings, and you get some statistics there. Now, how did I take care of my my repository, right? So again, this isn't right. I use the analog template. Right, I'm doing this manually. In the video, it's all done from the command line, which is probably better. It's just I was more comfortable doing this way. So I use this template, and then you've got to make sure that settings. You have to enable actions, pages. Where to go? Change it from deploy from a branch to here to GitHub Actions. Now, yeah, when you do it this way, right? When you create things, it runs these two things and it fails. And then when you update the info YAML file, it runs and updates, and that's okay. All right. The info YAML file, this was just the simplest thing in the world. Resistor, name, language. I kept the tiles, and I wanted, I was just going to put a resistor there. So I would have to buy 2 pins to have this design fabricated. Power and ground are for free. Excuse me. So you edit that, and then the actions run, and then in docs you have to change it, otherwise it'll keep failing. Now the way in the video you can kind of create the GDS and left directories and upload it at the same time. I kind of did it you know, most likely the most inefficient way, which is, I come back to code, and I said add file, create new file, and what I did is GDS, and then it seemed I had to kind of make up a fake file, right? Edit it, commit it, and then it created that directory for me, right? And then the same thing, the LEF, right, slash tests, and I just use .v. You commit the changes, and you can see what that looked like in my actions. Okay. So this was all me editing everything, right? And then this is me creating something in, oh, I forgot. You got to make sure your project source code is right. Which is, this is all in the video from Matt. Well done. But just, so you just edit your project, and you just have to use your top name, right? And that's the name I use for everything, right? Don't change anything else. So you can see all these failed commits. I changed that and it's right, but the GDS doesn't pass. The GDS doesn't pass because I'm creating things and deleting them, right? The docs runs every time. Oh, there's something probably I'm missing. No. So in the end, I created these files. And these are where I add the, like I add the LEF, I add the GDS, and then things start passing. And then this is deleting these test files I put in there, right? So the docs and the GDS run, right? But before that, adding, then deleting the LEF, docs and GDS runs. But here it passes because I added the LEF and the GDS. So in the end, right, if we look at it, everything worked. Didn't have a failure. And then here's the 2D preview. So it looks looks reasonable. You can even see your thing in 3D, which is pretty cool, right? And so that should be enough to get your particular design working. It's just in here, if it was an op amp, I would call it TTUM op amp and use my GitHub, use your GitHub name. I'll just open it up again. Add this pad frame, add these two, power and ground, short what needs shorting, and you could put the op amp inside of here, right? Rotating it. If you don't want to deal with the routing so much, you could probably move this over here, right, to get the pins that you need, right? So for an op amp, the power and ground are already there, so you just need V plus, V minus, and V out. And then if you can squeeze in the multiplier, you just need V in and V out, because we've configured it as a squaring circuit, so you don't really need two inputs. That should be it. I did ask Matt to make sure that there's something I haven't forgotten, because once I figured this out, the tiny tape out part was easy. It just went through first time. And of course, what I drew here was easy enough. There couldn't really be any, I didn't check DRC or anything like that, because I was just drawing rectangles. And I know that when I draw rectangles, you know, sometimes it doesn't like little overhangs. So I made sure everything was correct. Anyway, that's it.